Hi, Miss Lee. So I'm going to be investigating the function. It's on number 63 in the packet. The independent variable is the total number of teachers and students needed right here. And the dependent is the number of charter buses needed to take them. Okay, each bus holds 50 people. Each bus holds 50 people. And there are 440 students and 60 teachers. So, it doesn't really matter for this problem, students or teachers, so I'm just going to round it to 500 people. Okay, so now we're going to be defining it, and that includes a bunch of different parts. First, we're going to find the domain and range. So here I already have it up from the last take, but x would equal all positive integers, because for this problem you can't have a like half of a person. You can't have a half of a person or like a negative amount of people. That's why it's positive integers. And then for y it's the same thing. You can't have a half of a bus or a negative bus, which will be important for kind of finding the formula. So now we're going to see other significant features of the graph. So first we have to do the graph. So 50, since the number of people, the number of people is the independent. That means that'll be at the bottom, so it'll be 50, 100, and then it'll be 150 right here. And then for the dependent, the number of buses, we'll put it up here, and this will not be to scale, but it'll work for explaining the diagram of it. So for 50 people, we're going to have, for anywhere from 1 person to 50 people, we're going to have 1 bus. So we do the circle here, 50 here, and then the dot. Now, if we have 51 people, it automatically jumps up to here. So here, we're going to do the circle, which means everything excluding this dot. So it'll be to here, and we put the dot here. So 50 would still be part of the 1 column. But as soon as it gets to 51, it'll jump up to the 2 buses part of the graph. And then same for 3, we do the circle here. And so everything excluding this 1 point would then be 3 buses now. So some important, let's make a chart right here. Some important things, of course, are, just knowing that 50 would be 1 bus, but 51 would all, jump up to being 2 buses. Terrible line. So we do x would be 50, that equal 1. 49 would equal 1, and then 51 would equal 2. Same as 100 people would be still 2 buses, but then 101 would be 3. Okay, so that's our table of values. Now we're going to try to find a formula. Alright, so what I first see is that the 50 is all 50s, and it's the people divided by 50 to find the number of buses needed. So that would look like this. Let's say the function is f. So we're going to do f of x equals x over 50. X being people, and 50 would be what it would be divided by to get the amount of people, or the amount of buses needed. So this would be buses needed, and this would be the number of people going on the field trip. And this would be the capacity of the bus, how many people can fit in the bus. And that would work well for numbers like 50, 100, and 150. We'll do an example with 100 right here. Because if you have f of x, or it would be f of 100, that equals, we'll do it with a different marker, f of x equals, f of 100, f of 100 equals 100 over 50. This would work. As we can see here, that means f of 100 would equal 2. And that works here. If we go here, we see that 2, that is corresponding from this to this to here. That does work. But if we, instead of doing 100, we do, let's say 99, then this won't equal 2. It won't equal 2. It will equal something like a little bit less than 2. And that's not probably the right way to do it, but it'll be like 1.99. And you can't have a half of a bus. Therefore, this does not work for this given problem. It's not an accurate function because, like, you can't have, this does not have an, if we look at some points on the graph, like this doesn't have an output, or doesn't have like, scratch that, I don't know, I'm sorry. Okay. And so next we have identify the vertical or horizontal asymptotes. An asymptote is like something that a curve will get really close to, but it'll never quite touch. So that didn't touch. And it'll never quite touch, and it'll go on forever without ever touching. It'll get really, really close, but it will never touch. And on this graph, we don't have any asymptotes. This is a very unique graph in which, like, it's not really connected. There's like these spaces, but it works well for this graph because for things like this, where you can't have a half of a bus or a half, things like that, where it just wouldn't work. So like, if you like plug in different points, it'll always equal 1 until you get past 51, or then they'll all equal here until you get 100, or then they'll start equaling here. And like the corresponding inputs to outputs. So that's how we define it as number 63.